Hi, today we are going to be talking about section 7.3, which is all about areas of trapezoids. Trapezoids is a different type of two-dimensional shape than we worked on so far. So far we've worked on rectangles, squares, parallelograms, and triangles. A trapezoid is a quadrilateral, which means that it has four sides with one pair of parallel opposite sides. So this is a picture of a trapezoid. We see its four sides, 1, 2, 3, 4, and one of those pair of opposite sides is parallel to each other, which means that if it was going to continue in the direction it's going forever and ever, they would never overlap each other. They would never cross each other. So it's a four-sided shape with one pair of parallel opposite sides. Now, sometimes you'll see these turned on their side, and that doesn't change the shape. It still is a trapezoid. Just like if you were to turn a chair upside down, it would still be a chair. You just want to make sure that there's one pair of opposite parallel sides. Now, right here, this is not breaking the trapezoid up into two different shapes. This is just giving you an important measurement that you might need in order to find the area of a trapezoid. So here is the trapezoid area formula, which says you take area equals 1/2 times the height, which is right here, times the sum of the two bases, because the bases are the two parallel sides. So trapezoids have two bases. So again, 1/2 times the height times the sum of the two bases. And remember, the height has to create a right angle with the two bases, just like with parallelograms and triangles. It's the same rule. So here we have example 1. We're going to find the area of each trapezoid. Now I know this is a trapezoid because I see 1, 2, 3, 4 outer edges. And this pair of opposite sides is parallel to each other. Again, this line that's drawn here is not breaking the shape apart into two separate shapes. It's giving you an important measurement. So just like as before, we want to make sure we are showing our work all of the steps. So we write our formula first. Then we plug in what we know. So I look for the right angle for my height, which is the distance between the two bases. So that's 5. I make sure I put it in parentheses to maintain the multiplication. And the two bases are 8.5 and 11.5. Now, these are interchangeable bases. It does not matter which one you put as base 1 and which one you put as base 2, because when we add numbers together, we can add in any order. So now we follow PEMDAS to simplify. We have to do what's in the parentheses first. So I'm going to rewrite 1/2 times 5, and then these parentheses, 8.5 plus 11.5 gives me 20. And then we multiply. So 5 times 20 is 100. Half of 100 is 50. And I label my final answer meters squared because this is an area. Moving on to trapezoid 2. Again, this is a trapezoid because we see 1, 2, 3, 4 outer edges, and the parallel sides in this shape are vertical. So as I said before, if you flip a chair upside down, it's still a chair. It doesn't change the object. So just like this, if we turn a shape, it doesn't mean it becomes a different shape. It's still a trapezoid. So we write our formula. Area equals 1/2 times height times base 1 plus base 2. And we plug in what we know. We look for the right angle to identify the distance between the two bases, which is the 5. And then the sum of the two bases, 8 plus 4. And we follow PEMDAS to simplify. So I'm going to do what's in the parentheses. 8 plus 4 is 12. And then I start multiplying. Now for me, it's easiest to do half of 12, which is 6, times 5 is 30. And I label it millimeters squared. So as a reminder, the two bases are the two parallel sides. The height is the right angle in between the two bases. Same thing here, right angle in between the two bases. Last example for trapezoids. It says you can use a trapezoid to approximate the shape of Scott County, Virginia. The population is about 22,100. How many square miles make up Scott County? About how many people are there per square mile? So what we're going to do is first find the area of Scott County. So we're going to show all of our steps. We're going to write our formula. We start plugging in what we know. We know the height is the perpendicular distance between the two parallel bases. So here's our picture. Here's our bases. If it helps you to highlight, you are more than welcome to highlight. The distance between them is 20 miles. And the two bases are 15 and 38. So now we start simplifying. So I'm going to do what's in the parentheses here. So this gives me half times 20 times the sum is 53. And then I start solving. Half of 20 is 10 times 53. Anything times 10 creates another place value at the end, another 0 in this case. And that is how many square miles we have. Now the follow-up question was about how many people are there per square mile? Well, we know there are 22,100 people per 530 miles, square miles. We want to figure out how many people there are, unknown, question mark, or X, if we have 1 square mile. Now we learned this with our equivalent fractions. If we divide the square miles by 530 to get to 1 square mile, we have to do the same thing to our numerator. That gives me 41.7 people, which is not a realistic amount of people. And it is asking us for an approximate answer because it says about how many people. So we are going to write our final answer as 42 people per square mile. So again, we found the area using our trapezoid formula, and then we figured out this is called a unit rate from our ratios unit. We found out our unit rate to come up with how many people there are per square mile, 42. And that is the end of our 7.3 trapezoids, area of trapezoids notes.